I'm looking at the automated circuit discovery paper. How do I show the liquid text? Right now I'm trying to just open the paper in my preferred PDF viewer. Please download it. Oh, no wonder. Running out of storage space, and so it's optimizing the storage.
Liquid text lets you quickly look up defined terms and
Good thing it renames them. Through blah blah blah, effort and intuition. I'm thinking of the quote that when you're writing code, don't be as clever as you can, because when you have to debug it, you'll need to be twice as clever, but you were already as clever as you could be, so you're screwed. This paper systematizes the Mechainter process they followed. First, researchers choose a metric and data set that elicit a behavior. I'm curious more about these metrics. Data set, yeah. And when doing Mechainter experiments, often set, like with the IOI task, you have a data set. Oh, I guess the metric in this case is just if it names John or Mary correctly. Simple metric. But normally the data set is picked and you explore the fuck out of it until the examples are thoroughly understood, and then you work your way up. We automate one of these steps, finding the connection. So of these three steps of data set, metric, and unit, this is the step, unit. We propose several algorithms. So these are the questions I'm trying to answer. How does ACDC work? How can it be improved? Should probably write this. Oh, and how would I check? Automated circuit discovery. Automated circuit discovery. What does the other C stand for then? Think about this later. Or not. Oh, hey, it's Nix in there. I saw Goldwolski Dill. ACDC. Oh, one of the C's in discovery Makes up the last C in ACDC. ACD didn't have the ring to it, I guess. Selected 62 of 32,000 edges, all of which were manually found. This was a project I was excited about when I was at Remix. It was starting just then. I love tools. Tools and controlling passions are what separates from an animal. Researchers, blah, blah, blah. Reading the first paragraph. Much research views models as a graph. Yeah. Circuit is a subgraph. Not necessarily connected. Current approach, blah, blah, blah. Lots of manual inspections. That sucks, obviously. Identifies a workflow. Oh, that's handy. And automates part of it by presenting several methods to extract the graphs. First, we systematize this workflow, outlining the essential pieces. One step is to find a subgraph, which we do, blah, blah, blah. It's just saying the same thing again. A novel. I hate the word novel. Just say new. A web novel I like is Godclads, and they have the slang Nova for anything that's new, cool. Shit's pretty Nova. Subnetwork probing. Head importance score for pruning. Well, that suggests one way to improve. McIntyre attempts to explain blah 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 by understanding underlying algorithms. Neural networks. I swear to God. Finally, as a concrete example, given GPT too small, with a data set of sentences, okay, well, the sentences. Why doesn't it just. GPT-2 gives 18 or 19, but not with any two-digit number that is at most 17. This can be measured by the difference in probability the model places on completions 18, 19 or larger, and 17 or smaller. So this is logits, compare logit diff with 17. Well, with the right answer, which equals 17 in this case. Note that we use the term dataset to refer to a collection of prompts that elicit some behavior. Yeah, we don't train models. Research then corrupted to avoid any bias against particular digit completions, the O1 dataset. They attribute the greater than op to later layer MLPs and then find earlier components that identify the values. Attention. So I'm saying attention, but really it's the middle layers of the network. Then there's later MLPs that identify. Finally, they interpret the role of each set. They identify early components that respond to 17 and later ones that boost the importance of logits for years greater than 17. So I'd plug into 17 and see how it lights up. This is not the kind of idea I think Adria is looking for as an improvement, but visualization in 3D and VR. I should plug this in. The battery's starting to go. I want more outlets in my house. Up in the highlands, chasing cars, building guns and breaking hearts. Hey Andre, if you ever see this, well, it's not Saturday, but it is sunny, and it's Sunday, and I'm inside working. But what else can I do? Okay, let's see if I can distill this process. So you compare the logit diff of the correct answer with candidates which are picked out. You could pick that. Using a more powerful model. This is something that can't be done forever, of using a more powerful model, because that's the precise problem. But it can be done right now. Anyway, get data set, getter set, compare. See how the net or model lights up. There are equivalent steps taken in a growing number of additional works. So there's docstring, induction, and IOI. Let's see, in a docstring, I'm guessing something to do with Python's triple quotes to identify something is a docstring. Induction, seeing if something's copied. I forgot the induction had one. Described in brief in table 1 and in detail in 3 appendices. Oh, thank you. Tracer exproportion. Reverse. Probability difference. Could be logic difference. Verninders. Lee and Petuniters. Lay. Tokens beginning in the space have an underscore. All right, appendix. Quick skim of the appendices. Which appendices was it? F, J, and H? F, yeah, F, H, and J. Where's F? Ah. I, O, I. Components. Are those components that, well, are literally the negative or more like orthogonal to something? a circuit and a small model, a 4-layer attention-only transformer on Python code and some language, controls which variable name the model predicts. Zero 0.2, so this is layers 0, 1, 2, 3. Okay, so that's 4 layers. Although it only makes use of 3 levels of composition. We discussed below why we cut 0.2 and 0.4. Random data set, randomizes variable names as doc strings. ACDC generates the subgraph 18B. We perform a run with lower threshold recovering circuit. Okay, it looks like there's a trade-off here between some threshold and subgraph size. So heuristics for picking that better. To guess subgraph size. All right, I can just scroll. Select behavior, divide the network into a graph of subunits, patch activations recursively. Choose a behavior to analyze. Yeah, that's on you for the most part. Curate a data set. This part's hard. Compiled with tracer. Oh, right. For each task, we mention the metric used in previous work. All right. Okay. Define circuits. Represent the internals of a model as a DAG. What a fun word to say. Current work chooses the abstraction level of the computational graph depending on the level of detail of their explanations. Okay. At a course level, I'm guessing it'd just be like a whole MLP layer, whereas you might go all the way down to a single scalar. More granularly, separate query key value, QKV, activations, interactions between individual neurons. So a neuron is not a layer, it's a unit of a layer. Node connectivity has to be faithful to the model's computation, but does not fully specify its definition. Following Elhage or Nelhage, because his first name is Nelson. This guy, 10-inch player. That's supposed to be a smiley face. There. Many works consider the connection between components in non-adjacent layers due to the additivity of the residual stream, even though these are computed with dynamic programming, aka recursively in the actual implementation. Connectivity defines what's considered a direct or mediated interaction. See, for example, 2A, where B has both a direct output and an indirect. Let's see, it'd be something like B, oops, go away. O, I don't actually need to circle anything. A, something like this. Yeah, something like that. Section 3 formally defines a task, which we say is the same thing as a behavior. Depending. Once the DAG is specified, can search for the edges that form the circuit. So given a DAG, now we're starting to do some cutting. We test edges. Okay, if the edges are at the level of a layer, that's doable. By recursively activation patching, overwrite the activation value of a node edge with something else. Run a forward pass of the model. Compare the output values of the new model with the original model. One typically starts at the output Sure don't make this easy. Just go select. Why can't I just put it? Do I have to excerpt it? So this is a reversed top sort. Given that it's a DAG, it can be linearized. Because a partial order can be turned into a well order. Well, that's interesting. If you have a DAG like this, that's infinite. Well, it has a first but not a last, and reversing it will give it a last but not a first. I guess this what is first and last would just swap. So it would always have a first but no last. Still though. This idea of walking backwards. So if I'm like, oh, say C activates it the most. Oh yeah, you get this locality effect because you only have to look at how these ones are contributing, these three edges, and to see how much this one is contributing, say A. Let's do darker blue. I'll only have to look at this edge. So every time singleton edges can be compressed, it will depend on the granularity. Or let's say resolution. Why can't I sort by edited by date? Fine, but God damn it, which paper was it? It's automated circuit discovery, edited. Please don't have just deleted everything. Did it say edited in 2016? How? This paper wasn't even written in 2016. Very weird. Anywho, though. Example A, B, C, D. D has two dependents, but A has, or B has one. Let's do I. Then B's dependence on I will come straight from its influence on A because A would get 100% of the relative weight. How well does Rust handle DAGs versus just trees? I don't think Rust would do great with DAGs. That face one, unsure if it's abandoned or done. 10 issues. Activation patching varies. Some will do zero patching, others will use the average activation value. Kevin Wang, and don't know that guy, prescribe interchange interventions. Overwrite activation on one data point with another one. On the grounds, someone else argues on the grounds, interestingly before Kevin, but after Geiger, that zero and mean activation take the model too far away from actually possible activation distributions. Maybe? I don't know. I can see zero patching has an immediate appeal, but it does seem a bit crude. Taking the mean, I guess, depends on the data set. An argument for the individual one, but which might also be an argument for the mean patching, is that if it is doing between data points, if the task is being solved in the same way, then swapping data points shouldn't be too bad. But anyway, it swaps. After isolating a subgraph, one has found a circuit. Hell yeah. Can then formulate and test hypotheses about the functions implemented by each node in the subgraph. The circuit, you might as well call it the circuit now that you've gone through all this trouble of defining it, or at least identifying something with it. There is early evidence that ACDC is helpful for making new observations, such as the importance of surprising token positions that help small predict correctly gendered pronouns. So Dave is a great friend, isn't he? Did anyone know this paper? Chris Mathwin and Neil Nandan. Nope. The subgraphs generated on it show that MLP computations are more important than attention for this task. All three layers of layers have important roles. 3 and 5 are important components at name position, which must be used. Multiple incident edges. Incoming edges? I'm just gonna look up. Reviewed by Michael Albin for Apen. Different guy. I was thinking of some algebraic topologist. How spammy. Does this allow? Thank God. The MOP is 7 at the is position. Has the most incoming connections. Figure 22. Okay, so is this the most incident because of the yellow? Oh, I see a bunch are going to here. Later, layers 10 and 11 have the largest direct effect. So does this mean that these ones are directly connected, or is it only indirect? MLP7's importance at the is, spaces, right? Its output shows that the important drop my pen. Internal flow has 3 pieces. Where'd you go? First, layer zeros, attention head 4.4, and MLP0 using the name embedding for which they pass. Just looking for somewhere to lie down. But the rest of my house is cold. When I lie down, I'm reminded that it's colder, since the hot air will be in the air and not on the ground. Oh, that's another way of doing activation patching. Use a model to guess the most similar ones and then patch with their activations. Specify a threshold. Replace activations of connections between a node and its children and measure the effect on the output. Connections are removed if their measured effect on the metric is below some threshold, tau, instead of t or thresh. Recurse. Oh yeah, this will have to terminate since eventually the worst case you would just have a straight line graph and then some nodes on some influence on another node would be 100% and so above the threshold, unless you pick a stupid threshold. In this case, it's sort of for a Boolean task. Examples where xi are prompts on which the model's predictions have a notable pattern, and x prime I where it's not present. This notation is awful. Just use an array. We then use the activations of the models on a forward pass. So if M is model, x prime, act. Iterates from outputs to inputs to build a subgraph. At every node, it attempts to greedily remove edges without reducing the model's performance on some metric up to threshold. With nodes top sorted then reversed. Same. Let H be the subgraph that's being pruned and tau some threshold. How to evaluate. Thanks for bolding it. We let H be of x prime be the result when x is the input, but all edges not in the subgraph are corrupted. Replace with or overwrite with 2. This defines H, the output probability distribution of the subgraph under such experiment. We evaluate H by computing the KL divergence between G and H. Let me see if this makes sense. Well, if H just is G, the KL divergence will be 0. We let DKL be the average KL divergence. Appendix has alternatives. The order in which we iterate the parents is a hyperparameter. In our experiments, the order is lexicographically later to earlier. from higher to lower index. Okay, for a given layer, the order of picking parents would matter, I would imagine. Because of this greedy procedure for what seems like a task that would be MP hard. Subnetwork probing learns a mask over the initial model components. I guess this is how they zero them out. Using an objective. No wonder they use Rust for some of this. So H starts at G, is top sorted. For every vertex, for every parent vertex, edge? No, it's a W and V are vertices, and then the arrow between them is edges. H new is H minus that edge. If the divergence is less, then prune. Okay, this is gonna run a lot, but hey. At the end of training, we round the mask so that it will be a subnetwork. Tries to keep enough info so a linear probe can still extract linguistic information from the model's hidden states. In order to automate circuit discovery, 3 differences. No linear probe, KL divergence. Use the mask to interpolate between corrupted and clean activations rather than 0. Okay. Head importance score. Oh, these are all just different ways of pruning. Hisp. Lisp for hissy fit. Prunes all but top K heads. The receiver operating curve characteristic. I never remember what this is. This is 0 activation, so we generalize it. Does the method identify the subgraph? Does it cut out stuff that's not in the task? Okay. High true positive and low false positive. Receiver operating characteristic. We consider canon or canonical if you're a coward. Circuits taken from previous works which found an end-to-end circuit explaining behavior for tasks in table 1. Oh, the previous thing. It's canon because some guy found it. Many such guys. Circuit discovery is binary classification where edges are positive or negative for in or not in. But the circuit was recovered by ACDC at any threshold when patching activations with zeros. Area under curve on IY does better than their own. PR. PR and TPR again. Oh, false and true positive rates. Testing against humans. Well, mitigation for that one. This one cannot really be done for everything because it's expensive. Not run more, run longer. We studied induction task, measure KL, recovered with the 3 methods to the original. Run the circuit recovery algorithms in Algo 1 and Section 3, then measure KL on induction. Performs better with both corrupted and zero. I don't think having a model generate heuristics is not legit, considering that a model's already generating a guess. It's just a model's your brain, which is about as interpretable at the moment. The KL divergence that all methods achieve is lower for trained networks. All the methods get signal from the neural network's ability to perform induction. Related work. Pruning. Unlike us, it's typically concerned with compressing them. This is the part about, I've made this argument before. It's always bugged me how pruning seems concerned with some of the less interesting aspects of what's going on. To me, it's really interesting that you can, okay, like even Zor, with a very small model, I think it's like a 1/4 failure rate in training because of local minima. Add like 50 and then do it, and it's trivial. And then prune it, and you get I don't remember if you can actually prune it all the way down to 2 reliably. Smaller, but does Zor. And this training is like pretty much guaranteed to work. If it's smaller and it can do Zor. Like the idea, my intuition for it is that if you're doing a task, it's easier to find some solution to it, and a higher dimensional space makes this easier because you can find some answer. And once you have a answer, refining it to better answers is much easier than trying to solve something correctly the very first try. Also why alignment is hard, because we don't get that many tries. Generally our technique slows. Yeah, I'll bet. Our technique slow forwards passes. Spelling error. Causal interpretation, causal inference. Other work discusses the difference between indirect and direct. Removing subsets using direct effects as proxy for overall contribution. Nix and others introduced path patching. I remember this vaguely from Redwood 2, to analyze the effects of different subsets of edges. Instead of just the one activation, it's doing it across a set of them. In parallel, that guy, which was this? Well, that could be a lot of people actually. Sorry, Jiang Xuan? Jiang Xuan? Jiang Xuan Zhu. Okay. Jiang Xuan Wu, sorry. Computational subgraphs for interpretability. Training dynamics and residual models can be explained by shallow paths through the graph. MLP layers, oh, that's interesting, can be modeled as memory. That's a good flashcard. Then attention really is like attention. Conclusion. Oh no, wait. Residual transformer models have been modeled as the sum of all different paths through the network. Later work has used insight from looking at subgraphs to edit their behaviors. Okay. Workflow. Behavior. Then patch it. Then find a subgraph. Here, identify behavior. It will try to do the patching and discover the circuit. Wish I'd used this when I was applying to Nanda's stream. The behavior there I was looking at is an antonym. Seeing how a model can do left and right, discrete and continuous, etc. It's weirdly good at discrete and continuous. Large logit difference there. Syntax and semantics, simpler models can't do. Like sentences like the opposite of syntax is blank. The data is not discrete, it is blank, so on. They have limitations that prevent them fully automating step 3. Wait, that's step 3? Doesn't it help with step 2 as well? Conduct activation patching to understand which units are involved. Isn't it telling you what's involved? You could run it in some trivial way. They tend to miss some classes of abstract units, like negative name overheads, and it is sensitive. I can deal with it being sensitive. To address that, once a working config found, auto break it. I guess it's not that hard to break it. It's that if you have something that works, finding something else that works that's different. I'm thinking if there are multiple circuits, something like this. A head is very thin influence. Could this make the difference? That by its sort of linearity, I don't think so. I think that one. Oh, step 2. The methods we study don't identify both inputs to OR gates inside neural networks. Can arise from nonlinearities, 1 minus ReLU, 1 minus. Well, 1 minus x is not x logically. So it's like not max. 0. And this would be not 0. Oh, max is just or. 1 minus x and 1 plus x are the same thing. So it's not false or. Well, if x is 0, y is 1. If x is 0 and y is 0. Not x XOR y, which by De Morgan's rules would be true and, well, the not would cancel. Does the inner XOR get reduced? I find it interesting that AND is both min and multiplication, but XOR is addition and OR is max. So there's an asymmetry there. But this is getting out of hand, so I'm going back to this. It looks like the granularity is picked by the users. So starting out and finding a persistent network vaguely reminiscent of persistent homology would be handy, where you start with a whole network and you run on several levels. And use our granularity 3 times. I don't think I have the full feeling of ACDC, but certainly more than before. So let's write up a response to Andrea. How would I check that my change is an improvement?